Hey guys, welcome back to the 8-Bit Rams YouTube channel. Today we're going to be introducing buoyancy by using penny boats.
Remember, don't do anything in this video without an adult supervising and giving you permission. Okay, so the first step in any experiment is always the scientific method. So we're gonna go through the steps of the scientific method right now. So the other day I made an observation that some objects float in water while some objects sink. So that's just an observation I made about the natural world.
Next, we want to ask a question. What boat shape will allow the pennies to float or sink?
Then we're going to make a hypothesis, conduct our experiment, and then we'll have a conclusion.
Before we begin the experiment, we need to gather our materials. So first, we need aluminum foil, we need pennies, a container with water, and towels in case we spill some. We're going to be making boats out of the aluminum foil to see how many pennies we can carry. Keep in mind, you can make any shape you want.
You can make any shape you want out of your tin foil as long as it kind of resembles a boat. Okay, so I have my triangle boat right here.
I have my square-shaped boat.
Circle.
Circle.
Okay, so now we are going to begin the experiment. Now that we have our boats built, and we already know what shapes our boats are, we are going to predict. Do you think your boat is going to be able to float?
Absolutely.
Me too. How many pennies do you predict your boat will be able to hold?
I think mine can hold 1,000.
1,000 pennies? Wow. I think mine can hold just about 10 pennies. So now we're going to do the experiment to test out how many pennies the boat can actually hold before it sinks or falls. Okay. Want to begin putting the pennies? Okay, so my partner's boat had 9 pennies in it before it sunk.
Oh no! My boat!
That's okay. See, we tested our hypothesis, and you predicted 1,000 pennies, but we only got 9. So
sometimes
okay.
It doesn't work. It's okay if it doesn't work.
Now we're gonna try the triangle. Water. 1. Oh, and look at that. It's starting to leak. So my triangle boat was able to hold a lot more pennies. So you can see the differences in design may lead to different outcomes. But your boat may hold a different amount than both of ours. So now that we have our data, we can move on to the next step. So now let's learn a little bit about why this experiment happens, why these boats float. So first, to understand the experiment, we need to know the definition of some terms.
Starting off, we have matter, which is any object that takes up space. We go a bit more in depth with this on one of our older videos that we'll post in the description.
But any object you can see is matter, so like this, or pennies are matter, but the air is also matter, because it takes up space. And volume is the amount of space an object takes up. So 1 penny might not have that much volume, but the air in the room will take up a lot of volume.
Density is how much matter can fit into a particular volume.
So buoyancy is an object's ability to rise or float in liquids. So our boats, at the beginning of the experiment, they floated in the water, so they were very buoyant. But just a penny alone would sink in the water, so it is not very buoyant.
Can you name any buoyant objects?
Can you name any objects that would float in water? Just things you're saying. Like, for example, a rubber duck is a very buoyant object. If you have one in water, it will float.
Or a boat, any type of boat, as you can see.
So how does density and buoyancy work? So density affects an object's buoyancy, or its ability to float. So if an object's density is small, its buoyancy will be very high. So if an object's density is less than the density of a liquid, it will float, it will be buoyant. But if it's more than the liquid, it will sink, so it will not be very buoyant, like a penny. So if it is equal, the object will just be submerged in the water in the middle of the water, like
Halfway.
like a fish.
Yep.
Thank you for watching, everybody.